Okay, this is section 6.5, day 2, where we're solving radical equations like the one below. And in the first lesson, we just did some basic ones where you basically do algebra steps to do the opposite operation and cancel out like squares with square roots with squaring and all that type of stuff. Fraction exponents, you do the reciprocal, blah, 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 blah. All right, so in this lesson, we're going to do more complex radical equations. What's going to make them harder is they're going to have two radicals in them. And then we'll also do at least one real world problem involving square root. Okay, so if you want to jot down our first one here, you've got two radicals. All right, and so the process for solving them is you're going to isolate the radicals one at a time and then square to get rid of the square roots. All right, so on this particular question, I'm going to get this. I'd probably get the harder one alone first. I think that'll be a little bit easier. So I'm going to add root x to both sides. So that I have 1 plus root x. All right, and then I'm going to square both sides. And it's going to wipe out this part over here, giving us 2x plus 1. All right, and then one of the hard things here is now I have a binomial. And we talked about this in the previous lesson, is now we're going to have to make two of these and FOIL. And I messed that up. That should be an x there, not a 2. Okay, so this will just be 2x plus 1 on this side. And then we got to FOIL out the other side. So multiply 1 times 1, 1 times root x times 1. And then root x times root x is going to be square root of x squared. Okay, so now I'll start to clean up. So we have a root x plus another root x, so that's 2 root x's. And then here, the square root and the square cancel each other out, giving us just x. All right, so we got rid of one of the radicals. There's a lot of work, especially on this right-hand side. But now we have to isolate the other radical, the remaining radical, and get rid of it. Right, so to isolate it, I'm going to minus 1 and minus x so that we have just the radical on this side. So that would leave us with x and 0. And then on this side, we just have 2 root x. All right, and now there'd be a couple choices here. You could just square right away to get rid of it, or maybe we go all the way and divide by 2. Maybe let's do that. So we'll have x over 2 equals square root of x. Now we can square both sides again. All right, so this side will become x. And then here, this will just be like if I have x over 2 times another x over 2, that should just be x squared over 4. Okay, so now we have like an x squared and an x equation again. And probably the easiest way is going to be to get 0 on one side and factor. So another part, I guess, here is let's times it by a 4 to get rid of that divide 4. And then minus 4x. So now that we have 0 on one side, and now we can solve with factoring. Right, so for here, factoring, pull out an x, GCF factoring. And so one of our answers is going to be x equals 0. And then if we set this little factor, if we want that to be 0, then we'd have x be 4. That's that 0 product property. Right, so we get two answers of 0 and 4. So that one is definitely a lot of work. All right, but they're kind of fun. I found it in the past. These are a good challenge, and kids do pretty well with them. So, yeah, hopefully you got that one down. I'm going to throw one more at you, and I'm going to see if you can get as far as you can. It kind of starts like the last one. It's a little bit harder. Right, we got this giant boss man here, so we're going to have to all band together and take him down. Right, but yeah, give it a shot before watching the solution. All right, so I want to isolate one of the square roots first and get rid of it. So probably the easiest thing is if we add this quantity to both sides so that we end up with it canceling out on the left, and then we have 2 plus the square root of x plus 1, that little quantity. Now it's going to be much like the previous question where I'm going to square both sides. So I'm going to square this, and when we square that side again, we're going to have to FOIL. So the left-hand side is now all cleaned up. That's nice and pretty. But then the right-hand side is going to be a mess because we have 2 of these things, and we got to multiply them together. All right, but it's going to should look pretty similar to the last question. So I'm expanding it because of the square, and then FOIL. Okay, so 2 times 2 is 4. That's not so bad. 2 times that quantity is just 2 times the quantity. The inside 2 is the same thing. 2 times that quantity. And then the last 2, it's a little goofy, but basically, like if you have root 7 times root 7, that's just going to be 7. Because you'll have square root of 7 squared, and it'll cancel out. If you have root x times root x, that just becomes square root of x squared, or just x. So basically, these roots are going to cancel, and you just have x plus 1. So this thing times that thing, since they're the same root, when you multiply them, you get that thing squared, and then it cancels out. Right? You essentially get the square root of x plus 1 squared, and that just becomes x plus 1. All right, so now we got to start cleaning up and isolate the other radical. So I don't know, let's just do 4 plus 1 is 5, and then 2 of these plus 2 more is 4. And we still have the plus x on the end. Okay, and now get this thing alone. So that's minus x and minus 5. So we'd have 2x minus 4. Right, I'm minusing 5 and minusing x. Trying to save space here. Okay, and then on the last question, I divided by 4 here, and I kind of regret that actually. I think it'd be easier if we just square right now. I mean, it's not going to be easy at all, but in general, if we just square here, it might turn out to be not so bad. All right, so the right-hand side now will become, if I square this, I'm going to square both parts. I'm going to have 16 times an x plus 1. All right, so we got squared the 4 and then squared that thing, and it just canceled out the square root. I'm going to move that over to give myself a little bit more space. Right, because the other side we're going to have to FOIL yet again. So we have a 2x minus 4 and a 2x minus 4. Okay, so we're going to FOIL that out, and we're going to get 4x squared, and then minus 8x minus 8x plus 16. Okay, and on the right-hand side, if I distribute this, I'll get 16x plus 16. All right, and sorry I can't fit this all on one screen, so I'm going to have to scroll down. If you need to copy this down, make sure you got it down. All right, so now I want to get 0 on one. Oh, no, actually, let's combine the 2 minus 8x, so minus 16x plus 16. Okay, now I'll get 0 on one side, minus 16x and minus 16. So we'd have 4x squared, and we had negative 16x, take away 16 more. And we had 16 minus 16, so we get a 0. All right, and then this is going to end actually a lot like the last one. So to solve this, we can GCF factor. So pull out a 4x, and then set the two parts to 0. So if we set 4x to 0, divide by 4, we get 0 as one answer. And then x minus 8, set that to 0, and we get one more answer of 8. All right, so that's a pretty crazy question, and I can't quite fit it all my work on there, but hopefully you can go back in the video and see the rest of it if you need it. So if there's two radicals, you isolate them one at a time and then solve it from there. All right, final thing I want to do with you today then is go over one real world problem. Okay, so we've got this crater in Arizona, and distance formula relates the diameter of the ring in meters to the volume in cubic meters. What is the volume of the meteor crater? Okay, so we have the diameter already. That's fantastic. We just got to find what the volume is. So basically, we have two variables in an equation, d and v, and they give us the diameter. They say that's 1.2 kilometers. Oh, except to make this fun, this is in meters. Ugh. So 1.2 kilometers, if you times it by 1,000, that's, that didn't show up, but that's 1,200 meters. So that's what we're going to use for D. So we're going to put 1,200 into our little equation, and then 2, and then a third root V over 3/10. And so now we just got to solve that. So we want to isolate this root first. So I would divide by 2. It's just like a solved question we've done the last couple days. And then cube both sides to cancel out the cube root. So this is going to be a big number. That's going to be 216 with, what would that be? 6 zeros. 1, 2, 3, 4, 5, 6, I think. I'll check this on the calculator here in a second. But then we'd have this side, it would cancel out. So we'd have V over 3/10. And then multiply both sides by 3/10 to cancel out the divide 3/10. Okay, and that's going to get us a pretty big volume. Okay, so we get 64,800,000 cubic meters. So that's meters cubed for our volume, which makes sense, right? There's a big crater, so the volume inside of it's pretty big. But yeah, that's just a solving question using a real world story example. All right, so that concludes 6.5, which is solving radical equations. This video, we just did the harder ones that had double radicals. So isolate one of them at a time and get rid of it, and then isolate the other one and get rid of it. And then also one story problem here. So homework will have similar type questions. All right, thanks for watching.